In the shadowy depths of the Pacific Ocean, something strange is stirring. Scientists exploring the seafloor near a dormant underwater volcano stumbled upon something no one expected: a glittering field of golden orbs, 2.6 million of them, scattered in a perfect nursery pattern. They weren't alien, and they weren't artificial. They were eggs. This wasn't just any egg cluster. It was the largest egg-laying site of its kind ever discovered, and no one knew it was there. Who laid them? Why so many? And why here near a volcano? This is the true strange, and today we dive into a deep-sea enigma that has scientists both amazed and concerned. The scene is the summit of an extinct underwater volcano called Davidson Seamount, just off the coast of California and about 80 miles southwest of Monterey Bay. In 2023, a team from the Monterey Bay Aquarium Research Institute, NBARI, sent down a remotely operated vehicle, ROV, to explore the seabed at a depth of over 10,000 feet. The robot's lights pierced the blackness and revealed something extraordinary: a vast, shimmering field stretching across the seafloor. At first glance, it looked like a treasure hoard. But as the camera zoomed in, the researchers realized what they were seeing: golden egg capsules tucked into the nooks of rock and clustered along the ridges. They counted, then recounted. The final estimate? Over 2.6 million eggs. And not just randomly placed, they were arranged carefully in one massive reproductive site, a nesting ground the size of a football field, hidden in darkness for what could have been centuries. The answer was just as shocking. These were eggs from the Pacific white skate, a rarely seen species of deep-sea skate, a distant cousin of sharks and rays. Also known as Bathyroja spinosissima, this mysterious creature is known for its ability to live in extreme depths. But scientists had never seen anything like this. While skates are known to lay eggs, often referred to as mermaids' purses, no one had ever discovered a communal nesting site of this scale. Normally, skates lay 1 or 2 eggs at a time and scatter them across the seafloor. So why did thousands of these skates converge on a single underwater volcano to lay millions of eggs together? And even more perplexing, why here? Davidson Seamount is a sleeping giant, an ancient underwater volcano, no longer active but still warm at its core. The seafloor near it emits subtle heat, just enough to raise local temperatures slightly, and that may be the key. Researchers now believe the skates are using the warm rocks as a natural incubator. The eggs, nestled between volcanic boulders, are kept at a more stable and slightly elevated temperature compared to the freezing ocean around them. This could accelerate the embryo development process, which is critical in the deep sea where things happen incredibly slowly. In some cases, skate embryos can take up to 4 years to hatch. This strategy mirrors how sea turtles lay their eggs in sun-warmed sand. Only here, in the deep sea, it's geothermal warmth doing the job. But even that doesn't explain everything. Why did so many gather all at once? Is this a natural cycle we're just now observing? Or a rare, once-in-a-lifetime event? Some researchers think these skates may return here generation after generation, using deep-sea memory or geomagnetic cues we don't yet understand. This discovery isn't just a cool fact, it changes how we understand deep-sea life entirely. Until now, we assumed skates, like many deep-sea animals, were solitary. This communal nesting shows a level of coordinated behavior that hints at complex biological instincts and possible communication. And there's another layer to this. The nest is located in one of the few protected deep-sea marine sanctuaries in U.S. waters. Had this site been in an unprotected zone, it could have easily been destroyed by deep-sea mining, trawling, or oil exploration before we even knew it existed. The timing of this discovery couldn't be more crucial. As global interest in deep-sea mining grows, especially for rare earth metals, areas like Davidson Seamount are under increasing threat. If the skates chose this spot for a reason and we lose it, the ripple effects could be irreversible. These are not just fish eggs. They represent an ancient, fragile process unfolding in the last unexplored frontier on Earth. Now that we know this kind of behavior exists, the obvious question is, how many more of these massive nurseries are out there? And how many have already been destroyed before being discovered? The ocean floor is vast, mostly unmapped and mostly unexplored. Some scientists believe there may be dozens, even hundreds, of similar nesting grounds for skates or other deep-sea species. But without more exploration and protection, we may never know. It's also raised a new mystery. Is this skate population in danger or in a boom cycle? 2.6 million eggs sounds like a success story, but it could also indicate overcompensation, a species under threat, laying more eggs to ensure survival. There's still so much we don't know. At The True Strange, we look for facts that don't just inform, but unsettle. The golden eggs of Davidson Seamount aren't just a marvel of marine biology. They're a symbol of how much remains hidden and how fragile that hidden world really is. This wasn't science fiction. It wasn't ancient myth. It was real, filmed by robots in the deep, and yet it feels like something out of a dream or a warning. What else is out there, just beyond our reach? What other secrets lie curled in the darkness, waiting to hatch? We often look to the stars for wonder, but maybe we should be looking down, into the oceans, into the cracks between tectonic plates, into the ancient, slow heartbeat of our own planet. The 2.6 million golden eggs found near Davidson Seamount are a reminder. Earth is still writing mysteries we've yet to read. And in the deep, where light never shines, life still finds a way, golden, glowing, and strange. This is The True Strange. Subscribe for more real mysteries and let us know in the comments, what do you think this is?